So here we're given a rectangle between 0 and 8 in the x direction and 0 and 2 in the y direction. And we've got three regions, R1, R2, and R3. The curved function here is x to the 1/3. The straight line is x equals 4y. And we're going to do some different regions around some different axes. So first one we're going to do is region 2 about the x-axis. So region 2 is right here. And we're going to go around the x-axis. Well, as you can see, if we do that, we're going to have an open center. So this is going to be a case where we have the large radius minus the small radius. So you can see we're going to go from 0 to 8. There'll be pi in there. And it's going to be the large radius squared minus the small radius squared. We're going around the x-axis, so it will be a dx because our slice is going to go this way. It's going to have a width of delta x. So we really just need to identify the large radius, which is right here. It's the line from the x-axis up to the function y equals x to the 1/3. So we have 0 to 8. This first one's going to be x to the 1/3 squared minus our small radius is right here. And it's just this linear function, which right now is solved for x, but we can very easily switch that to be solved for y. 1/4 x, or if you like, x over 4. So there's our small radius, so x over 4, the quantity squared dx. So there's the definite integral that will give us that volume. This particular video is not about solving these. Next one, we're going to do region 1 around the y-axis. So that's this region up here. So it's bound by the the y-axis, the line y equals 2, and this function y equals x to the 1/3. But now since we're going around the y-axis, our slice is going to go this way, which is going to be a delta y. So we're going to want this thing solved in terms of y, which is x equals y cubed. Now we only need, this is going to make a nice solid for us, and it's going to go up from 0 to 2, as we can see there. And we just need the main radius, which is from the x-axis out to this function. This function again is y cubed. So it's pi times y cubed squared dy. And we're all finished on that one because it does not have an open center. For the last one, we're going to do region 1 again, except this time around the line y equals -2, which would be some line down here somewhere. Let's just draw it in just as a reference point. So this is going to be the line y equals -2. So this region here, let's color it in a little, is going to be rotated around this line y equals 2. Once again, we're going to have the open center. And we know that it's going to be pi. And it's in the x direction, because our slice will be vertical, it's going to go from 0 to 8. We can see that. So we just need to identify our big and small radius. So let's put it in here. There's our small radius. There's our big radius. Now notice, wherever I put this big radius, it stays the same. So it's actually just a constant. And we know the distance from here to here is 2. Well, the distance from here to here is also 2. So it's going to have a radius of 4. So squaring that 4 is going to be the large radius squared. This smaller radius, now this one varies depending on where we are at. And it was the function y equals x to the 1/3. But x to the 1/3 only covers us up to here, x to the 1/3. We still have 2 more units, and that 2 is always going to be the same. So our small radius is going to be x to the 1/3 plus 2, the quantity squared, dx. And so there are our 3 definite integrals.